Hi again, this is Terry A, and I wanted to do a supplemental video to emphasize the rolling sky effect or the vanishing point for the dome. So I'm going to demonstrate with 3 different models, this glass model that I had and 2 other aluminum foil models of the dome. And so I have the camera on the microwave plate, representing the Arctic center, looking up at Polaris, and we're just going to move the camera away from Polaris in all directions. And at some point I'm going to tilt the camera to give more of a rolling effect, as if we're, going way out, to the breadth of the outer circumferences, like to Australia, Cape Horn, Argentina, past the 45-degree mark of our equator. So here we go. I'm not tilting the camera, I'm just moving it away. It's tilted a little bit because I have to go over the edge of the microwave plate. Now I'm moving away in one direction. And so the camera has its own effect in terms of opposite, but now I'm moving in the other direction. Okay. And the point is to show how you see different aspects of a dome. So if my dome was wider, you wouldn't see outside the dome. So, and that's the point. You would see different aspects of the dome. So just think of what the other, whatever you see outside my glass dome here would be dome, would be sky. It would be a different portion of the sky. So actually that's a good effect, because you would see different portions of the sky. So now I'm going to tilt the camera, because to give the rolling sky effect. Because all you would see is dome and different portions of the dome, whether the dome, the star constellation is closest to Polaris, or the ones further down to the wider circumferences. So the further you go away from the Arctic center, you're going to see more of the bottom portion of our dome, the lower parts of the circumferences, the most wide portions. I'm at a prong here, so I can't go any further with that. And take notice of should be a moon somewhere, so you could take notice of what the moon looks like. There it is. So rolling, so what the position of the moon, where's that? And so that's with the glass dome. Okay, this is with one of my aluminum domes, and as you can see, it's hard to get it lit, so I'm going to try, and hopefully you can get a chance to see something. So I'm just going to move it away from Polaris. And I'm tilting to get over the edge of the microwave edge. Going back to Polaris, moving away from Polaris from in a different direction. Not tilting too much. And again, it's just to show that you see different aspects of the sky when you move to outer latitudes. So that's why you get the effect, especially once you get to the 45-degree mark, you're going to see, because that is the dramatic effect. Even with the dome, the steep from 90 to 45 degrees, there's the steepest. From 45 degrees to 0 degrees of the dome, it's quite shallow. So I think that also has an effect on the appearance of the sky to people past 45 degrees. That is the most dramatic effect of the dome. So the combination of that and you know, and the latitude at 45 degrees is, I believe, what causes the dramatic effect between 0 degrees latitude and 45 degrees, and between 45 degrees latitude and 90 degrees latitude. And I don't say 90 because no one is at the 90 degree part. No one's been there. So I usually say from 45 to 80 degrees. So now I'm going to tilt more. And let me just find my moon so you can see the effect. Okay, that's where the moon is. So we're going to tilt, because it will be tilted this way. So we're tilting. You can see the different effects moving away and tilting, and depending on the direction you're going in. I don't know. So the camera is like my view from wherever I'm going from. And these are not necessarily actual views that people, because there are places that people don't travel on the plane. So most of our travel is towards the upper flow of the Nile. So that's what I call the upper Nile flow. And it's not past the continents. You know, much of the land is towards the upper Nile area, and not in any other direction. So this is just a general view. So the moon may be doing different things. And again, I think this will affect the sun too. The angles of the sun rising, I think, will be affected by this dynamic. You know, people talk about the angles, and I think it's more of a visual effect, perhaps. Okay, this is my wider dome, and I'm not sure where the moon is on this, but I'm gonna, hopefully you see, but that's Polaris. And the plain strips of paper are just constellations that are close to Polaris. The circle, the pieces of paper with circles on it, kind of represents the zodiac constellations, the 12 zodiac constellations. And then the pieces of paper with a horizontal line on it, they represent the outer circumferences of the dome constellations. So it may be a bit busy, but I was trying to show more more dramatically just how you see different aspects of the sky. So this is a busy model. So I hope it still helps out. So I'm moving away from Polaris. So you can see, and the arrows just show, you know, if I was doing the rotation spin experiment, that would just show which way we were going. So you see some numbers. The circles, again, are like the zodiacs. There's 12 sheets of paper with circles on it. So I'm tilting to get over the edge of the microwave plate. So now we're going back. I don't want to make this too long. We're going away from the Polaris, from the Arctic Center. Going away, going in all directions from the Arctic Center. And again, whenever you don't see my aluminum, that would be another portion of the dome sky. So now I'm going to start tilting to see more of the effect of the rolling effect. Because when you go into way those far vectors, those far latitudes, that's where you get that dramatic rolling effect, and the moon, I believe, appears to inverse. So I'm having technical difficulties with the cord and try and get around these prongs of my microwave grill. So yeah, maybe one more. And one more this way. Okay. Alrighty. Thank you again, and I hope that helps.